Hello everyone, I am Ajikumar, Assistant Professor Mechanical Department from Rohini College of Engineering and Technology. In this video, we are going to discuss about the subject Finite Element Analysis and the subject code is ME8692. We are going to discuss an important topic in Unit 1, that is weighted residual method. The method of weighted residuals is a powerful approximate procedure applicable to several problems. For non-structural problems, the differential equation of the phenomenon can easily formulated. For such type of problems, the method of weighted residuals becomes very useful. For structural problems, we are using Rayleigh-Ritz method to solve the problems. For non-structural problems, we are using weighted residual methods to solve the problems. The aim is to determine the unknown function, mainly y in differential equation, probably the assumed approximate function for y. On substituting this assumed solution in differential equation, we get residual and it is expressed as r of xi, that is a1, a2 and a3. a1 and a2 are unknown parameters present in assumed trial function, and the assumed trial function is y is equal to f of x1 for a1, a2 and a3. The a1 and a2 and a3 are the unknown parameters present in the assumed trial function. Trial function should satisfy the boundary condition, and the weighted residual method meets the parameters a by satisfying integral of wi into r of xi for a1, a2, a3 into dx should be as equal to 0. So the type of weighted residual methods are, the main four types of weighted residual methods are point collocation method, subdomain collocation method, least squares method and Galerkin's method. So in this video, we are going to discuss two problems in weighted residual method. So after discussing these two problems, definitely you will have an idea to solve the problems in weighted residual method. The first problem is, the following differential equations are available for a physical phenomenon, that is d square y divided by dx square plus 50 is equal to 0, and the limit given is 0 to 10. And the trial function is y is equal to a1x 10 minus x. Some problems directly they will give a trial function, but in some problems we want to assume the trial function, and that trial function should satisfy the boundary conditions. Here the boundary condition is given as y of 0 is equal to 0 and y of 10 is equal to 0. That is, when x is equal to 0, y is equal to 0. When x is equal to 10, y is equal to 0. And we want to find the parameter a1 by the following method of point collocation, subdomain collocation, least squares and Galerkin. So by solving this problem, first we want to verify the trial function. The trial function should satisfy the boundary conditions or not. That is, y is equal to a1x 10 minus x. First we want to apply the first boundary condition, that is when x is equal to 0, y is equal to 0. When applying the first boundary condition, we should get the answer on the both side of 0. So that is, it satisfies the boundary condition. When we are applying the second boundary condition, that is x is equal to 10 and y is equal to 0. So when we are putting x is equal to 10 in this y equation, 10 minus 10 becomes 0. So the both sides we will get 0 as the answer. So the second boundary condition is also satisfies. So we can able to solve the problem easily if it is satisfies. So the first method is point collocation method. So the trial function y is equal to a1x 10 minus x. So then we are multiplying the x term inside the bracket, that is y is equal to a1, 10 into x is 10x and x into x is equal to x squared. So 10x minus x square. Then we are differentiating the term y. dy by dx, with respect to x we are differentiating. Dy by dx is equal to a1 into 10, because the x becomes, when we differentiating the x term, it becomes as 1. So 10 into 1, that is 10, minus when we are differentiating the term x square, we will get 2x. So 10 minus 2x. Then we want to again differentiate the term d square y divided by dx square with respect to the x samely. So we will get at 10 becomes 0 and the minus 2x becomes minus 2, because when we are differentiating x we will get 1. So minus 2. So minus 2 into a1 is minus 2a1. Then we want to substitute this d square y divided by dx square value in the given differential equation. The given differential equation is d square y divided by dx square. So that is r is equal to minus 2a1 plus 50. So the residuals are said to be 0 then minus 2a1 plus 50 is equal to 0. Then we want to find the parameter a1 answer. When this minus 2a1 is equal to 0, this plus 50 term is when we are turning this plus 50 into the other side, it will give us minus 50, and the both minus term will be cancelled, and we will get the answer of parameter a1 as 25. So a1 is equal to 25. So the solution is y is equal to 25 into 10x minus x square. So the second method is subdomain collocation method. In this method, the formula for this method is integral of 0 to 10, that is r into dx is equal to 0. So r is equal to, we know that minus 2a1 plus 50 into dx. So then we want to integrate this term. When minus 2a1 into dx, integral of minus 2a1 into dx will become as minus 2a1x in the next step. And 50 into dx, integral of 50 into dx becomes plus 50 into x. So then we want to apply the term 0 to 10. First we want to apply the upper limit 10 and we want to apply the lower limit 0 after that. So when you are applying the limit, we will get the same answer in this subdomain collocation method also, that is a1 is equal to 25. So the solution is y is equal to 25 into 10x minus x square. So the third method is least square method. This method requires I is equal to 0 to 10 r square into dx. So when we are taking as r squared, it will take much time to solve the problem. So we will have another formula to solve this problem, that is dou I divided by dou a1 is equal to 0 to 10 r into dou r divided by dou a1 into dx. Same r is equal to residual is equal to minus 2a1 plus 50. So then we want to differentiate the term dou r by dou a1. We want to differentiate with respect to a1. So we will get the answer as minus 2. And dou I by divided by dou a1 is equal to 0 to 10 minus 2a1 plus 50 into minus 2 into dx. So the requirement is dou I divided by dou a1 we want to equate to 0. So 0 to 10 minus 2a1 plus 50 into minus 2 into dx is equal to 0. First we want to multiply the term this minus 2a1 plus x plus 50x, that limits 0 to 10. We want to put the upper limit first and we want to put the lower limit next, and we will get the same answer, a1 is equal to 25 in this term also. And the fourth method is Galerkin's method. Mostly Galerkin's method only they will ask in university questions. So just we want to give importance to solve the Galerkin's method. So in Galerkin methods, it is 0 to 10 wi into r dx is equal to 0, and the trial function is y is equal to w. We want to take the trial function as the weighing function, that is y is equal to wi, that is equal to a1x into 10 minus x. So we want to substitute in that formula 0 to 10 wi r ds. For wi, we want to put the trial function y's value there. So a1x 10 minus x into minus 2 a1 plus 50 into dx is equal to 0. By solving this formula, also this method also, we will get the same answer as a1 is equal to 25. So trial function y is equal to 25 for the all methods. So we will get the same answer as 25, 25, 25, 25 in the all four methods. So then we want to discuss the next problem, that is problem number 2. This problem number 2 is the following differential equation is available for a physical phenomenon, d square y divided by dx square plus 500x square, that is equal to 0, and the limit given is 0 to 1, and the trial function is y is equal to a1 x minus x cube plus a2 x minus x power 5. So here two parameters are given. In the last problem we have discussed this only one parameter, that's a1. Here two parameters are given. So that after that the boundary condition is y of 0 is equal to 0 and y of 1 is equal to 0. That is, when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 0. Then we want to find the parameter a1 and a2. Sorry, here it is mentioned as a1, but we want to find this both parameters a1 and a2 by the following method, that is point collocation method, subdomain collocation method, least square method and Galerkin's method. So the solution is y is equal to a1 x minus x cube plus a2 x minus x power 5. That is a trial function. Same we want to follow the first problem, that is we want to differentiate the first term dy by dx with respect to x. We want to solve that is a1 into 1 minus 3x square, because when we are differentiating the x term we will get 1, and when we are differentiating the x cube we will get 3x square. Then plus a2, the same like when we are differentiating x, it will get us 1, and when we are differentiating x power 5, we will get us 5x power 4. Again we want to differentiate d square y divided by dx square, that is equal to a1 into minus 6x, because when we are differentiating the term 1 it will get us 0, and when we are differentiating 3x square we will get 6x plus a2. When we are differentiating 1, we will get 0, but when we are differentiating 5x power 4, we will get 20x cube, because 4 into 5 20, and 4 then x power 4 minus 1, that is 3, so minus 20x power 3. So d square y divided by dx square is equal to minus 6a1x minus 20a2x cube. So the residual is r is equal to minus 6a1x minus 20a2x cube plus 500x square. So the interval is 0 to 1, that we want to divide this domains into 0 to 1 by 2 and 1 by 2 to 1, because here we want to find two parameters. So r is equal to minus 6a1x minus 20a2x cube plus 500x square is equal to 0. First the domain 1, that is 0 to 1 by 2, put x is equal to 1 by 3. We want to take any term between 0 to 1 by 2, and we are assuming here x is equal to 1 by 3. So r is equal to minus 6a1 for x, we are substituting 1 by 3, minus 20a2, we are substituting x 1 by 3 power 3 plus 500 into 1 by 3 power square is equal to 0. When we are solving, we get an equation of 2a1 plus 0.741a2 is equal to 55.55. Put equation number 1. And the domain 2 is 1 by 2 to 1, and we are taking the x term as 2 by 3. We are assuming x term from the limit 1 by 2 to 1, and we are assuming that x is equal to 2 by 3, and we are substituting 2 by 3 for x in the domain 2, and we will get the formulas a1 plus 1.481a2, that is equal to 55.55, and it is equation number 2. When we are solving the equation a1 and a2, we get the answer as a1 is 18.53 and a2 is equal to 25. We can able to solve these two equations using equation mode in calculator, and we will get the answer as a1 is equal to 18.53 and a2 is equal to 25. So y is equal to 18.53 into x minus x cube plus 25 into x minus x power 5. Second method is subdomain collocation method, 0 to 1 or ds, because the limit given is 0 to 1. So 0 to 1, integration of 0 to 1 to r dx is equal to 0. So the interval 0 to 1 divided into two domains, the same for collocation method, 0 to 1 by 2 and 1 by 2 to 1. For domain 1, 0 to 1 by 2 r dx is equal to 0. We want to substitute, and we will get the equation as a1 plus 0.4166a2 is equal to 27.773. So take the equation as 3. And domain 2 is 1 by 2 to 1 r dx is equal to 0, that is minus 6a1x minus 20a2x cube plus 500x square into dx is equal to 0. So we want to put the limits, and we want to integrate the term, and we want to put the limit. For when we integrating minus 6a1 in x into dx, we will get minus 6a1 x square by 2, because x dx is equal to x square by 2. X cube into dx is equal to x power 4 by 4, and x square dx is equal to x cube by 3. So when we are applying the limit, and we will get the equation as a1 plus 2.083a2 is equal to 64.813, and take this equation as equation number 4, and solving the equation 3 and equation 4, we will get the answer as a1 is equal to 18.50 and a2 is equal to 22.23. So the solution is y is equal to 18.50 into x minus x cube plus 22.23 into x minus x power 5. And next, least square method. So least square method, I is equal to 0 to 1 r square into dx. I already mentioned the first problem. When you are taking r squared, it will take much time to solve the problem. So we will use the other formula as dou I divided by dou a1 is equal to 0 to 1 r into dou r divided by dou a1 into dx. And the domain 1, dou I divided by dou a1 is equal to, the limit is 0 to 1 by 2 r into dou r divided by dou a1 into dx. So r is equal to minus 6 a1x minus 20 a2x cube plus 500x square, and dou r by dou a1, that is with respect to a1 we are differentiating the term, we will get minus 6x. So dou I by dou a1 is equal to 0 to 1 by 2 minus 6 a1x minus 20 a2x cube plus 500x square into minus 6x into dx. Then we want to multiply this two terms, and dou I divided by dou a2 is equal to 0. Same, we want to, with respect to a2, we want to differentiate the term, and we will get as 1 by 2 to 1, 120 a1 x power 4 plus 400 a2 x power 6 minus 10,000 x power 5 into dx is equal to 0. So we will get two equations as equation 5 and equation 6. When we are solving this equation 5 and equation 6, we will get the answer as a1 21.11 and a2 is 20.28. The solution is y is equal to 21.11 x minus x cube plus 20.28 x minus x power 5. And the fourth method is Galerkin's method, that is 0 to 1 wi into r dx is equal to 0 for domain 1, 0 to 1 wi r dx. In the Galerkin method, the trial function is assumed as the weighing function, that is y is equal to wi is equal to x minus x cube. The same r is equal to minus 6 a1x minus 20 a2x cube plus 500x square. So for the domain 1, we are putting 0 to 1 by 2, and we will get the solution as a1 plus 0.4832 a2 is equal to 30.651, and we want to take this equation as equation number 7. And for domain 2 is 1 by 2 to 1 w2 into r dx. We want to take the same trial function x minus x5. In trial function 1, we will take wi, w1 we will take as x minus x3, and for w2 we want to take as x minus x5 parameter of a2. So then same r is equal to minus 6 a1x minus 20 a2x cube plus 500x square. When solving this equation, we will get a1 plus 1.84382 is equal to 61.035, and we want to take this equation as equation number 8. When solving this equation 7 and 8 in the equation mode in the calculator, we will get the a1 parameters 19.862 and the a2 is 22.34. So the solution is y is equal to 19.862 x minus x cube plus 22.34 x minus x power 5. So all the same four methods we solve the problems. In the second problem, we want to find the two parameters a1 and a2, and the first problem it is only one parameter is given, so we didn't divided the domain. But in the second problem, we divided the domain, we divided the limit, and we done the problem. And acknowledgement is the main reference of this presentation is from the textbook of Dr. S. Senthil and Mr. R. Panidas, the Finite Element Analysis by Lakshmi Publications. Thanks for watching this video. For any queries related to this video, you can contact me in my WhatsApp number 8754330058, and my mail ID is AJIKUMAR AJIKUMAR.AERO@gmail.com. Thanks for watching. Thank you so much.